Hello everyone, this is Hemalata, Assistant Professor, Department of Agricultural Engineering, SNS College of Technology. Under the concept of solar energy conversion, we are seeing the lot of topics. Today we are going to see about the topic about the pyranometer. Pyranometer, it is a device which measures the solar radiance on the flat surface, which capturing the radiation in watt per meter square. And a pyranometer or solar irradiance sensor is used for the climatical research and weather monitoring. However, in recent years, the use of pyranometers in the solar energy sector has increased. This lecture will explain more about what it measures, what it is used for, how it works, and the types of pyranometer sensor. A pyranometer measures the global irradiance in watt per meter square. The global irradiance is the amount of solar energy per unit area per unit of time, which comes from the direct and diffuse solar radiation. Direct radiation or direct sunlight, which travels straight from the sun to the earth without interruption by clouds or atmospheric particles. Diffuse radiation is the sunlight that is scattered by water droplets, air molecules, and reflected from the buildings or trees or any other things, etc. Measuring both the components is crucial for understanding the solar energy availability at a particular site. The pyranometer sensor converts this global irradiance into an electrical signal that can be measured. What a pyranometer used for? It is main role in solar monitoring. It measures the intensity, duration, and availability of the sunlight. The major factors commonly used in solar energy sector: agriculture, meteorology, climate science, and building and urban planning. The The global irradiance is the which will measures the total whole radiation which hits the horizontal surface. Direct incidence is the it hits the surface perpendicularly to the sun rays, and diffuse is a scattered solar radiation. The types of pyranometer is a thermophile, photodiode, and spectral pyranometer. The major principle of operation is this device features a radiation sensor that absorbs the solar energy and converts into an electrical signal. This signal is then used to determine the intensity of a solar radiation. The sensor technology is a thermophile sensor, which is a common type where a blackened surface absorbs the radiation and generates a temperature difference. This difference produces a voltage that is measured. Then photovoltaic cells, sometimes used to directly convert solar radiation into an electrical current. The design components or optical components: radiation sensor, mounting and alignment. Pyranometer have a glass or optical dome that protects the sensor and allows the sunlight to enter. Radiation sensor, the core component that detects the solar radiation and generates a corresponding electrical signal. Mounting and alignment, typically mounted on a horizontal plane, through adjustment may be needed to account for tilt or orientation. Based on this, there are three types of the pyranometer: thermophile pyranometer, photodiode, and the spectral pyranometer. First, we are going to see about the thermophile pyranometer. In this, um, it is a type of pyranometer which will measure the global radiation by means in the uh, thermophile sensor. It is a series of thermocouples connected in series, uh, which is designed to measure the broadband of the solar radiation flux intensity. Then the thermoelectric deduction principle is used whereby incoming radiation is almost completely absorbed by the horizontal blackened surface over a wide wavelength range. The result in increasing of temperature is measured by the thermocouples connected in series parallel to make a thermophile. It is necessary to protect the black detector coating against the external influences which may affect the measurements such as precipitation, dirt, and wind. Then photodiode pyranometer. In this, it which uses a photodiode for measuring the solar radiation, which mostly used for the large scale. And to achieve the particular design, significant correction measuring the program utilities, we are using the lot of photodiode pyranometer for measuring the solar radiation. The advantages is high sensitivity, fast response time, low power consumption, and wide spectral range. Then spectral pyranometer, which will measure the um, solar radiation from using the wavelength ranges. For different wavelength, it will measure the solar radiation intensity. It is an advanced type of pyranometer designed to measure the solar radiation for different wavelengths rather than providing a single integrated measurement of global solar radiation. The spectral pyranometer measures the intensity of solar radiation at specific wavelength. It is used for studying the solar energy optimization and climate studies. Then application is totally, it is mostly used in all type of field, solar panel performing monitoring, solar radiation mapping, weather forecasting, climatic studies. Overall, the pyranometers are crucial for measuring the global solar radiation, provide valuable data for various scientific, industrial, and environmental applications. Proper calibration, maintenance, and understanding of measurement principle are essential for obtaining reliable and accurate data. Thank you.